don't know. Okay, so starting at the top, there are some examples of what to do in different situations. The main thing that you need to know for all the examples is this is power over root. And if you can remember that, then you can get the setup right every single time. So to go from this to this, it's the power over root. And we'll see this in the examples. Rational exponents. Exponent refers to the power. Rational refers to any number that can be represented as a fraction. And as you can see, there are fractional exponents. So again, power over root. You can even continue power over root and so on. And we'll be writing this for a lot of the examples. Power over root. Okay, so for the first example, it says write in radical form. Radical refers to the square root symbol. So here we have x 1/6. Remember, it's power over the root. So this would be 6th root x to the first power. But x to the first power is just x, so we really don't write that 1. The answer is just 6th root of x. Okay, number 2, they take it up a notch. We have t to negative 3/8 power. With this negative, what we do is we have it as 1 over t to the 3/8. Then from here, it's power over root. So we'd write it like this. 1 over t to the 3rd power and 8th root. In previous lessons, we would have gotten rid of this radical, but that's not the point of this one, so we're just going to keep it like this. So in these examples, we're going from a radical to exponential form. So here we have the power is 7, and then the root, it's not written here, that means it's a square root. So to write this, y power is 7 over the root, and that is our answer.
So is that y to the 7/2 power, or is that y 7/2?
Y to 7/2 power? I don't know.
That's power, okay.
Yeah. Okay. Then number 4, of course, they take it up a step with the number 4. We have the 5th root out here, and then we had 2 different terms, like numbers in here. So we have to apply this 5th root to both of these. And what that would look like, for 3, it'd be to the 1/5 power. And then for x, it would be 2/5. So again, power over root. Okay, so far so good. Next, okay, now we're going to bring in just numbers and evaluate for values. So here it says 36 to 1/2 power. So remember, power over root. So this would be 36 to the first power, square root. Obviously, some of these numbers would never really be written out. It'd just be square root of 36, because 36 to the first power is just 36. Square root, when it's just the second root, we don't write it there. And then square root of 36, you could do it in a calculator if you need to, but it's just 6. Now we repeat. Okay, number 6, 64 to the 2/3 power. Again, power over root. So this would be 64 squared cubed root. Okay, So here we would do 64 squared in a calculator. 64 squared. So 64 squared is 4,096. We could use the method we learned last chapter where we break this all up into factors. But honestly, you should already be good with that. So just use a calculator and find cubed root of 4,096. So in a calculator, I would do 3 cubed root 4,096 is 16.
Here's what I found.
Stop, Siri. Chill. I would actually find the cubed root of 4,096. That's kind of funny. Okay. Okay. Number 7. We have a negative exponent again, so we're going to write this as 1 over 3,125 to the 1/5 power. Then from here, the 1/5 power would look like this, 5th root of 3,125. You could break this up into factors if you wanted to, or plug in the calculator. 5th root 3,125, and it comes out to 5. So this answer is actually just 1/5. Yes.
Can you use a calculator on this?
No. I'm going to show you another way. Okay. So for number 8, you ready for number 8? Okay. So number 8, 9, and 10, now we're multiplying and we're combining exponents. So just going back to the basic concept, if you had like x squared times x to the 4th power, this would be 2 x's and another 4 x's, which would be x to the 6th power. So you would add the exponents. Whoa. And with division, if you had like x to the 6th power over x to the 4, you would have 6 x's on top, 4 on the bottom. You'd cancel them out and be left with 2 x's. So you are subtracting. You can subtract the exponents. So this would then equal x to the 2nd power. So that's what we're going to do with the fractions. We're either going to add them or we're going to subtract them if it's division. So for number 8, we have the same base right here. We're just going to add these exponents. So it'd be 2/7 plus 3/4. When you add fractions, you need to have a common denominator. So here, the least common multiple will be 28, so I'm going to multiply this by 4, multiply this by 4, multiply this by 7, and this by 7. Get 8 over 28 equals 21, plus 21 over 28. And then this equals 29 over 28. So we can write the answer to this as x 29 over 28 power. Or you could write it as this. Both are correct, depending on what format they're looking for. Next one is division. So we're going to subtract the exponents. So we'll do 3/5 minus 1/10. We need a common denominator, so multiply this by 2, multiply this by 2. I get 6 over 10 minus 1/10 equals 5/10. And then 5/10 equals 1/2. So then we get x to the 1/2 power, or square root of x, same thing. Number 10. 10 is weird. It has a negative exponent, so right away I'm doing 1 over r to the 4/5 power to get a positive exponent. Then what they want us to do is to get rid of that rational exponent out of the denominator. So the way we can do that, and I know you wouldn't have thought of this on your own, but now that you've seen it, it'll make sense. We're going to multiply by this number. The reason why we chose 1/5 is because we're going to multiply this by this, and we're going to add those two, and you get r to the 5/5, which is r to the first power, which is just r. So this times this is r, and then this times this is r to the 1/5. You could turn it into a radical if you wanted to, but this is what the answer key had. You could also write it as 5th root of r over r. Yes.
Can't you just like, you said when it's negative, you just flip it like 1 over.
Did it work?
I got a different answer.
You got a different answer? The answer key said this.
I'd say that means you're wrong.
Well, it doesn't mean I'm always right. I'm not always right.
Why are we doing this? Like, what makes that question
Simpler.
Is just conversion of
We're
or-
playing math. I don't know. I guess we'll see if it comes up in some of the later lessons. So one of the things that we talked about yesterday was making fourth quarter a little bit more interesting and kind of switching things up a little bit. One of the ideas was to do quizzes homework instead of Schoology homework once a week. So that's what we're going to do today. We're going to kind of play a little game instead of the Schoology homework. So there's actually going to be 2 parts, part 1 and part 2. Part 1 is simpler questions like this, and then part 2 is these types of questions, but I promise it'll feel a little bit simpler because they like repeat the same type of problem instead of like giving you a new or harder problem each time. So part 1 looks like this, part 2 looks like this. Just like with Schoology homework, I'm looking for 80% or higher for full credit, and I'm actually going to give you double homework points on this because there's 2 assignments. So yeah, try it out. I'm going to post the link on Schoology, so you'll just go to Schoology and grab the link and then start the assignment, and it's like a competition as well. Yes.
Can we use our phones?
No, I want you to use a laptop, please. Yes. Yes.